100% attention, concentration, everything is required, right? So you might think that this is easy. You might feel like this is easy. But okay, some of you guys might have done these things in schools as well, right? But I don't think you would have learned in this detail that I'm going to teach today, right? That is Newton's laws of motion. Right? Now you need to come to a state where like you do not know anything. Right? किसी देर दान्ने नहीं मोना हरे ओलुगे तीन वाला Newton's laws of motion क्या ने मेरे का ही केला अमतक कर लगा right? Forget about it. Completely forget about it. Try to upload only what I'm saying, right? How many Newton's laws of motions are there? Because I told you like you do not know anything, right? How come you say it's 3? Anyways, now guys, there is 3 Newton's laws of motion. There is 3 Newton's laws of motion. There are 3 laws of Newton's laws of motions. I'll be taking 3 separate sessions to discuss these 3 Newton's laws of motions. You might feel like, okay, this is too much time. We won't have enough time to complete the Newton's first law itself today, right? That much content is there. Newton's first law. So guys, Newton's first law. Okay. So sorry, you asked for the PDF and then sorry. Okay, so I couldn't say that just now I saw. Sorry about it. Anyways, I will send the PDF after the class, right? So just give me a sec, guys. I'll send that. Right. Okay. Yeah, school teacher has covered 3 Newton's laws of motion in one period. Yeah, you can do that in O levels, right? You can do that in O levels, but not here, and we are not going to do that. Right? Okay. Newton's first law. So guys, Newton's first law. In Newton's first law, what Newton says is, if an object is at rest, if an object is at rest means it's not moving, it's at rest. Or else, if an object is in motion, or else this can be at rest. Consider an object which is at rest. Consider another object which is in motion, but the object B should be in uniform motion. Let's assume it is in uniform velocity motion. If it is performing a uniform velocity motion, what is its acceleration? 0. It doesn't have an acceleration. It doesn't have acceleration. If an object is either at rest or at motion, and if that motion is a uniform velocity motion, it is said that these objects will not change its state of motion. It is said that these objects will not change its state of motion unless you apply an external unbalanced force. මේ object එක A කියන object එක සහ B කියන object එක වා external force එකක් apply කරේ නැත්නම් එයාලගේ state of motion එක වෙනස් කරන්නේ නැහැ යාළුවා. They will not change their state of motion. If it is at rest and if we do not apply an external unbalanced force, like if we do not apply an external unbalanced force, then it will remain in rest forever. What object at the object force apply external unbalanced force apply කරන්නේ නැති තාක්කල් ඒ object එක forever rest. And also, if an object is in uniform velocity motion, then object එකක් මොකක් හරි uniform velocity motion and it will not change its state of motion. That ඉතින් මොකක් හරි object එකක් is my bandwidth low, guys? Yes. Give me a sec, guys. Give me a sec. Right. Okay. You need to understand this well, right? This makes sense. This part makes sense. It's not a difficult thing. You need to understand this well. If this object is in uniform velocity motion, and if you do not apply any external forces, it will forever maintain that motion. Is it practical? Is it practical? If you ask whether it's practical, because like when we consider atmosphere, when we consider, okay, what was I saying? Like I was saying, when this object is performing a uniform velocity motion, and let's assume we are not applying any unbalanced forces. කිසිම unbalanced forces එකක් apply කරන්නේ නැහැ කියලා හිතමු. If we do not apply any unbalanced forces, this should forever move with uniform velocity. That is what is said in the law. But is it practical? Yes, it will not be practical in our real case. It will not be practical because of this air resistance. There's air resistance, right? When an object is moving in, like හිතන්නකෝ vehicle එකක් තියෙනවා, right? Vehicle එක neutral ගන්නවා. එහෙන වේගෙන් ගිහිල්ලා acceleration එකකින් ගිහිල්ලා neutral ගන්නවා. Which means on the engine no external force is applied, neutral and hari, which means in uniform velocity. But after a certain traveling a certain distance, it will come to rest, right? Why is it? Although we do not apply an external force on the engine එක මත force එකක් apply නොකරට on the wheels there's friction. Wheels මත friction. External force එකක්. Friction කියන්නේ external force එකක්. Air resistance. Air resistance. External force. Because of that, it's going to come to rest. It's going to change its motion. But as I know, while I was studying, of course, I just wanted to find about this concept more, right? And I just went through some experiments in Google and all. There was something called some experiment is done, and that object is allowed to move in uniform velocity inside a loop, and that object is still performing that motion forever. It's in a lab, right? Somewhere in lab, and that was done because of these magnetic fields and all, right? So do not think in detail. They have done such experiments, right? Like Samanya, Newton has told this. Do we know that this is true or false? We need to check this, right? So for that, they have performed the experiment, and it's valid, right? It's valid. It works. It works still, yes, right? They have used a special way of magnetic fields and all that. So let's forget about that. So simply, if an object is performing a uniform velocity motion, and if you do not apply an external force, it will remain performing the same motion. What if I apply if now let's assume this object is moving in uniform velocity. What if I apply F in this direction and F in this direction? Will it still be moving in the same velocity, or will it come to rest? Yes, guys, the thing is, I told you one important word. Okay, we have applied an external force. We have applied two external forces actually. But it is not unbalanced. It's balanced. මෙහෙන් F දුන්නා, මෙහෙන් F දුන්නා. Balanced. We have balanced it. If you need to change the state of its motion, you have to give an unbalanced force. If unbalanced force. Unbalanced force. Right. Okay. What if you give 2F in this direction? Now it's unbalanced once again in that direction. Unbalanced, which means the state of the motion will change. Uniform velocity will change, state change. So simply, if you need to change the state of these two objects, you need to apply an unbalanced force, unbalanced external force. This is the simple story. So is that it for Newton's laws of motion? We have not yet even started, right? Write down the topic, Newton's first law. Newton's laws of motion, the main topic. Newton's first law. Newton's first law.